So I got a few questions on implicit differentiation and a specific question in chapter 3.4. So maybe the same thing we'll look at in a second. So let's go to the specific question real quick. Share screen. All right, so you should be able to see my screen now. So let's go to that specific question. It was chapter 3. So we'll go back to, where are you? Over here, so I can get that question. All right. So I've updated the homework grade. As right now, I'll be updating the quiz grades later tonight. If you have any problems with the quiz, please let me know. As long as you submit your work, that'll be a big help. Okay. But please make sure you are submitting the homework, submitting as you put in the stuff. Okay. I don't think it will automatically submit, so make sure you are pressing the submit button. It should automatically submit. I don't know why it doesn't. I don't know why it doesn't. So you see 3.4. Question 8. All right. Yeah, these questions. So now let's see if I can share this question. It's kind of hard to share the question here. So it says marginal propensity to consume. The consumption function of an economy is as follows, where C of X is the personal consumption expenditure and X is the personal income, both measured in billions. So I have the function C of X is equal to 0.74x plus 98.85. Find the rate of change in the consumption with respect to dC dx. Right, this is called the marginal propensity for income. Now, anytime it's asking for the rate, they want to know rate. What they really mean is find the derivative. So what is C prime of X? And nicely enough, since this is a linear function, we can just use the power rule where the constant is going to drop. Okay, that constant is going to go away, and the derivative of this is just 0.74. And that's it. That is your answer for that. Yeah. So I don't know if you had harder questions on there. If you had questions that involve more than just a linear function, then you'd have more as your answer. But really, it's just find the derivative. Just because, again, I don't know if it's talked about enough on here. If you're given C of X, then the derivative, spelled correctly, spelled not right. So the derivative, you can write the derivative as C prime of X. You can write it as C prime. Okay. You could write it as dC over dx. Okay. There's a lot of different ways you could write derivative. This just happens to be one of them. Okay. So that's all they want is the derivative of that. Now, let me see if I can get to the other types of questions, which was probably in chapter 5. Chapter 5. I don't know when we come on implicit differentiation. But that was the issue. And yes, I understand implicit differentiation. And I tend to do implicit differentiation a little bit differently. So look like that's it. No. Probably on this look at X 4. More derivatives. Okay, yeah, let's see this. Let's try 5.6. 5.5. No implicit. All right, let's go 5.6. Check out which one. Oh, I was wrong. It's chapter 3. Okay. So chapter 3, 6. So I personally don't like the way they do this. So let me, again, I'll show you what I have, and again, maybe I can show this to you. All right. So you should be able to see. I don't like the way they do this. That is a headache and a half. Okay. It's terrible. Okay. So here's, yeah, you can, it's fine. You can solve for y. Is there implicit differentiation? Yeah. So solve by implicit differentiation. So let me show you the shortcut. Let's say we had this one, which I can't see it too well. It says 3x squared plus y squared equals 4. So 3x squared plus y squared equals 4. Okay. So let me back to here so I can see this, so you can see my screen as well. Right. So here's how I don't like I said, we can write dy dx. Okay, that's fine. All right, the concept, what's happening here is when I'm taking the derivative of this, I'm taking it forward to x. But the problem here is that that's not x. Okay, so what we do instead is we are going to say that that dy is equal to dy times dy dx is equal to dx. Okay, the idea is that that cancels out. So the concept here is a nice, I'm doing that right here. So the idea here is this means take the derivative according to y, and this is a way we can do that when we're taking the derivative of x. So this is accounting for the fact that this was originally a function that was specifically meant to be taken the derivative of x. So what we do is, I don't like to write that because it's a pain. I just like to write y prime. Okay, so the idea here is that anytime you are taking the derivative according to x and you have y, just attach a y prime to it. Okay, so I'll show you what I mean. Take the derivative. What's the derivative of this term? Sorry. Derivative of this term. Oh, no, here, very well. So, I hope you can hear me. So take the derivative of this term, and we have what, 6x? Now we take the derivative of y, and that is 2y, but anytime we take the derivative of y, I will attach a y prime. Not y, sorry, that's not right. A y prime. And be careful that don't make it look like a y group. So y prime equals, and derivative constant is 0. From here, my next goal is to get that by itself. So first, I will subtract 6x over. So 2y times y prime is equal to negative 6x. Then divide by 2y. And I have y prime by itself. I have my derivative. So that is negative 6. Now you want to reduce negative 6x becomes negative 3x over y, which is your answer. Okay, so that's the concept. Anytime you have a y, just attach a little y prime to it. Now these do get a little bit harder. Try this. There we go. So I need to be patient. So let's say my function was x cubed plus y cubed plus 8y minus 7, which is equal to 0. Right. So take the derivative. Now, take the derivative of x, easy enough. That is 3. Not what I need right now. 3x squared. Take the derivative of y. Now, again, because this is y, that is going to be 3y squared times y prime. Again, another derivative of y, that's just going to be plus 8 times y prime. Anytime I take the derivative of y, I'm going to include that with y prime. Now, derivative constant is 0, so that's just 0. That's gone. That's fine. Now, I need y prime by itself, so first I'm going to subtract x squared over it. So 3y squared y prime plus 8y prime equals negative 3x squared. Factor out your y prime. So basically get your y primes, bring them outside. So y prime times 3y squared plus 8 is negative 3x squared. Now we get y prime if you divide both sides by 3y squared plus 8. Can't reduce that, so that's it. Negative 3x squared over 3y squared plus 8. Now, the only issue you may come across is that your sign, you could have this written as 3x squared negative 3y squared minus 8. That just means your negatives on the bottom side of the top. Okay, so don't stress that. If you get the same numbers, but all the signs are backwards, it's fine. It's perfectly that. These are equivalent answers. Okay. Now, what the really fun stuff occurs. So do you have that? Oh, that looks like that's as hard as that gets. Let me see if there's any more. That's 3, 6. I think that's as hard as it gets. So you should be good from there. Let's see. Yeah, you should be fine. If you have any specific questions on 3, 6, just let me know. Let's talk about the test then. Talk about the concepts that are on the test. So, test 9 questions. You have an hour to get it done. Okay. So, first and second derivative. So basically find h prime of t and h double prime of t. Okay. Limits. All right. You're going to have questions on limits. Hint. Always simplify first. Always simplify first. Okay? It is okay to simplify and then take the limit. And that's honestly what you do. Every time, simplify and then take the limit. All right? So more derivatives, and you have several derivatives. You have derivatives of log functions, so natural log functions, derivatives, you have derivatives E, power rule, derivatives of rational functions, so square root functions, power rule, quotient rule, product rule. Okay, all your derivative rules. All right. Find a tangent line. Okay, so basically take your derivative, plug in your value, get the slope, and then put it in slope intercept form. Or basically, your final answer should be in slope intercept form. So once you have your slope at the point, to give your point, you need to find your slope. So once you have your slope and your point, create your equation. Right. Oh, you do have derivatives of exponential functions as well. Will be asked implicit differentiation. That's on. as well as profit and marginal profit functions. Profit, marginal profit functions. That's pretty much what your test. There is another couple, one question when you talk about rates of change and defining overall rates of change. So, yeah, make sure you have your rate of change homework done. Okay. What I mean by that is, let's see here. How fast something is changing or how much something is increasing or decreasing, given the situation. And it's kind of hard to explain without giving the exact answer. Let's see if I can find that section. So let's see here. Probably 3. Got check your files. Trying to find a good question or good section. That rates of change stuff. So six, 3, 6. That begin with. So yeah, it's a topic from 3, 6. It is that implicit differentiation question section. But yeah, so yeah, so the line number 5 from your homework from 3, 6, you should be able to go back and go to your scores and look at the question number 5 from 3, 6. All right, if a car leaves an intersection traveling west, its position 4 seconds later is 22 feet from the intersection. At the same time, another car leaves the same intersection heading north, so its position 4 seconds later is 30 feet from the intersection. Speeds of cars are at that instant of the time are 7 feet per second and 14 feet per second, respectively. Find the rate at which the distance between cars is changing. So the idea here is we have one car going west and one car going north. Now the one going west at 4 seconds, so at t equals 4, its position is 22 feet. So looks like it's x equals 22 feet. So here t equals 4 seconds. This is y equals its position is 30 feet. All right. Now the rate of change, okay, this guy's going west at a rate dy or dx dt. All right. The rate of change at x point in time is 7 feet per second. 7 feet per second. The rate of change in y is up. Dy dt is 14 feet per second. And what they want to know is they want to know dz dt. How fast is the distance between the cars changing? So now this is a right triangle, which means, and I'm trying to find the hypotenuse of the right triangle. So first, I am going to need to actually find what z is. Okay, z of t will say, specifically after 4 seconds. So here we have x of 4 seconds is 22, y of 4 seconds is 30. So do your Pythagorean theorem, and I just close my calculator, so I'm just going to do it here. So calculator, second square root of 22 squared plus 30 squared gives me 37.2. 37 point, we'll say 2022. I don't want to round that much. Okay, that's all I got. Okay. So that's my z of 4 seconds. Now, basically, I know at t equals 4, x is 22, y is 30, v is 37.2022. And I have it right. So erase some stuff. I'm going to use this formula that x squared plus y squared. And I'm going to take the derivative over the top. Because I want to find dz, how fast they are changing. Now, that means I'm going to have a 2x times dx dt plus 2y. Now, this is where I do like to write the dx dt instead of x prime and y prime and z prime, mainly because I have so many different variables. I prefer to do the dy dt and dz dt is equal to 2z times dz dt. Now, the nice thing is I have almost all the information. Okay, I have x is 22, so 2 times 22. I have the rate of change in x, that is 7 feet per second, so times 7, plus 2 times y, which is 30 times the rate change of y14. That is equal to, I'm kind of through here, 2 times z, which is at 37.2022 times dz. Now my goal is to get dz dt by itself. So I'm going to go ahead and solve what I have on the left side here, 2 times 22 times 7 plus 2 times 30 times 14. That gives me 1,148 is equal to 2 times 47.02. 74.4014 dz. So I take 1,148 divided by 74.404. I get that 15.4 approximately, because they say the one decimal here. Approximately 15.4 is dz. So it'll be very similar to that concept. Okay. That covers everything in your test. All right. So there is a test review. It's okay. Okay. Honestly, it's not as good as just making sure you can do all the homework. If you can do all the homework, you can do the test, because that's where these questions are coming from. So they'll be very similar to your homework questions. All right. I think that's everything. So good luck.